Hi everyone, I'm really excited to host Vishu Bhooshan. He's an associate at Zaha Architects and works at Computational and Design Research Group in London. He leads the design research with computational geometries with specific interest on structure and fabrication aware tectonics, which incorporate digital form finding, topological optimization, statistical learning. He also leads the development of software agnostic computational framework to explore the above. Vishu teaches at architectural computation and architectural design Bartlett postgraduate programs at UCL. And I have been following Vishu's work from like Digital Futures workshop, all the various platform where Vishu shares his work. Like I really admire work and can't be more excited for this interview.
Thanks for the invite and the introduction. It's a pleasure being here and talking to you. It's a real pleasure. Thanks for the invite again.
No, no problem. Vishu, can you share some highlights from your career and what were some key defining moments which got you into technology in architecture and research?
Mm, yes, yeah, I did my since my did my BArch in Pune, in India. I was kind of interested in geometry, but we didn't know what tools were available. We are kind of using at that time still very AutoCAD 3D and early versions of Rhino. So we are still figuring it out, but in general, there was like a lot of interest in geometry. It's kind of, I think, in the family because both my dad is also an architect. He was interested in these kind of geometrical things, and my brother as well. So they guided me well, and then did my master's at the Architectural Association Design Research Lab, where we got exposed to a lot of the coding aspects, looking at processing, JavaScript and Java, and then slowly getting into core level coding in C++. So this they were general interests, I would say. And it's also a bit of the schooling background in India, where in the for my 11th and 12th grade, there was already an option to choose computer science as a subject, and I chose that, and so I had a bit of understanding of how to write code while I was in school. So that kind of helped to grasp quite a lot of things when we started getting into creative coding at the DRL, and subsequently joining Zaha in 2013 as part of the computation and design group. So initially, when we joined, there were only like the four of us in the team. So I learned quite a lot from the other three who were in the team at that time. They taught me how to write code for architectural softwares like Maya, Rhino, and how to use it in actual design. So it's not like only writing code, but code for design research. So, and that's where the major focus is for us as a team.
I see. And like with all these transitions into technology, like was there any point you felt it very overwhelming about learning these things and like the atmosphere? Like were there any like challenging moments in this journey?
Yeah, for sure. Learning learning how to code is quite challenging. You need to go through. So you need to first of all understand what you're writing code for. So you need to read a lot of papers. And these papers are not very visual, right? So you need to read them multiple times just to understand. So those are kind of difficulties generally you face when you start off. And then also looking to debug things, you struggle quite a lot. So those things are, so you need to put in quite a lot of effort to learn these things. But yeah, there were these forums online. You go through Stack Overflow or forums in Rhino, for geometrical forums in other institutes, trying to understand what people have done to solve similar issues, and then figure out what is the best way forward. So we kind of understanding what others are doing. That's kind of a critical main path, and understand that takes a bit of time.
I see. And you have like very multiple interests across various disciplines. And how do you keep up to date with all these developments and like stay at the top?
Yeah, it's yeah, Twitter, kind of following people on Twitter. That's kind of the major way to keep abreast with what's happening in technology, and then we have these collaborative projects with industry partners and other collaborators. So that's also keeps us abreast with technology, uh, what what people are currently investing their time in, and then we try to contribute in that. So that's how we, yeah, major source would be, I would say, Twitter is kind of a major source, and then I we kind of go through all the institutes, academic institutes like ETH Zurich, UCL, at the AA, what the students are doing, what the PhD candidates are doing, even at IAC and on even West Coast, US. So we have kind of affiliations, academic affiliations in these countries as well. So we tend to follow their papers, so new papers which come out, so we know what's happening or cooking in these places.
Got it. Yeah. And can you show us like some insights about the coding at Zaha? How is like the tech stack and things you do?
Yeah, sure. Let me share my screen. Mhm. Are you able to see my screen?
Yep.
Yeah, yeah, so maybe I skipped the presentation, the introduction, which Mayur already said that, yeah, these are our two affiliations at the Computation and Design Group at Zahadid Architects, and we also run a studio with Tomaso and Shajay at the University College of London, Architectural Computation. Yeah, as I said, like I'm part of Code. Code is currently, which is acronym for Computation and Design, started in 2007, and yeah, it's been 15 years, and every year we kind of grow by one person on average. So currently we are 15 people. So it was started by Shajay, Patrick, and Niels. I think there were only two people when they started, and then subsequently now we have come up to 15 people. Yeah, so since its inception, we were kind of, so this was another way, one of the mandates for the team was to create this interdisciplinary network of collaborators, and we had to develop that network. And that's also a reason why, answering your previous question, how do we try to keep what's happening on the technology side. It is through these interdisciplinary collaborators we kind of build our networks on, and that's why we are kind of aware of what's happening. And also Patrick brings in quite a few of the some of these interesting pilot projects, which kind of start off our investigations in certain fields, like when we got into high resolution 3D printing with Stratasys, or and then now Shajay does similar things for the team as well, bringing in these kind of collaborative projects. Yeah, so our research, as you might have known, is also kind of based on geometry. So that's why, like, our libraries are developed on geometries, because they are kind of the shared language, and also uh, like a language for collaboration with our collaborators. Yeah, like coming to the coding part, yeah, most of the members in the team kind of code. So that's kind of, we favor first principles to write our own code to understand the algorithms better, and it also helps us integrate it into the design pipeline better because we understand uh, what's happening, what's the algorithm actually doing. So we kind of, in this is where we need to look up ad papers, understand their, uh, if there is no computational equivalent, we understand through papers and try to implement our own. But now there are like a lot of platforms out there which also gives you the code, so which is kind of easy to see and implement on top of it or integrate it into our workflows. Yeah, so as I was saying, as a group, we are interested in design, coding for design. So it's all of these tools or stack is to augment design intelligence. It is to aid at design, give as much information as possible at an early stage about structure, about fabrication, or any other performance criteria we want to attach. As a stack, yeah, like we, on one hand, we need to develop the core stack, uh, which is currently we develop that core in C++ framework, and then try to have plugins into all the platforms the office uses. So, which is predominantly Autodesk Maya and Rhino. And then more so now with machine learning, we have to integrate with Python, and then Revit through Rhino inside. So that's kind of the core stack. We kind of keep trying to keep updating our framework on, but the focus of it, let me see. Yeah, the focus of the core stack is kind of split into these two aspects, which is kind of content creation and content delivery. So on the so predominantly the stages of the project. So on the left, focusing more on early stage design, and on the right, focusing on at the later stages where you like detailed design, where you need to rationalize geometry or get in costing. So these kind of so yeah, so we have a role in depending on projects. Some projects we are involved at a very early stage on the left, so we need tools there. In some projects we are involved at a very later stages, so then we need tools corresponding to that. Yeah, that's the current kind of the stack we have, which is plugging into the different softwares through plugins. Yeah, it's kind of getting interesting when we are trying to connect to all of these softwares. And as I said, like, yeah, all of these, like it's, we learn from our contemporaries and from history as well. So we look at a lot of, this is not an exhaustive list, but we look at a lot of computational tech related things at ETH Zurich, looking at the interactive geometry lab there. They have this library called the libigl, which we kind of, so there, uh, um, libigl is kind of a header only paradigm. So it's again based in C++, and we kind of aligned our framework to be similar thought process, that it is header only, so you don't need to build uh, dependencies. So that was one of the reasons. And then they also have a viewer, geometrical viewer, which are independent of the software. So you can do quick test and sandbox testing to test if the algorithm works. And then once you are happy with it, then you can plug it into all the softwares we use. Similarly, looking at the Polyscope, which was kind of developed by a student there, a PhD student at the Geometry Collective at the Carnegie Mellon University. Uh, we we are also, we kind of use this is Keenan Crane's heat method and developabilize on the left and right middle one, and then they developed a similar kind of interface like libigl, creating Polyscope, which also has its own viewer to create these kind of sandbox environments. And also more coming to the AEC side, yeah, looking at the Block Research Group and their framework called Compass, which is based on Python, but similar idea. So they can integrate into the different workflows also, but they also have a viewer where they test, sandbox these testing and then develop on top of it. Uh, Other ones we look, yeah, like we kind of look into this kind of NVIDIA. So this is called the GPU gems. We look at algorithms there. It's kind of uh, like looking at geometry processing and occlusion, lighting, how to use the GPU. So these are kind of, this is not an exhaustive list. I just put in a few to get an idea. And on the framework, yeah, so we are kind of at this is kind of a current moment. So we kind of have like a core framework, which is kind of developed inside using people at code, and then develop an API, which so the core is developed by only a few people, so it doesn't so it can accommodate for changes, but not many people are contributing there. But the code developer part, so that is where you need the API. So people who know a bit of coding can start using the API to make these function calls and create these sandbox applications and test the algorithm. And then subsequently, if you don't know any of the coding, then you kind of use the plugins, which kind of come at a later stage in Maya or Unreal or Rhino. Um, yeah, and you can see the varying ranges of topics we kind of have. One is the architectural geometry, which is like a core interest. Under that, we have structure, fabrication, and sign distance fields, etc. Looking at data and machine learning, and yeah, some utilities and display aspects as well. Yeah, this is our framework. Yeah, like the documentation is still quite early, so we are still developing that. Yeah, this is kind of the first versions of it. And yeah, so similar kind of drawing from the knowledge of all the examples I cited, we kind of developed like our own uh, like a sketch format, where this is like the sandbox environment, where you it's similar to processing as well in that sense. So you have these kind of setup, draw, update main methods, where you write call these methods from our framework, and then you press play and check uh, check. So this is a custom viewer based on OpenGL, and then testing out if the code actually works. And then once we are happy with it, then this becomes a plugin. So this one's currently looking at, I think, the video here is looking at some kind of structural systems, looking at form finding, using kind of best fit for like, so it's given any input geometry, it's finding the nearest compression shape. So that's the kind of the algorithm which is running. Yeah. Mm.
That's that's amazing.
Yeah, so those yeah, there are more things, but yeah, if you want to stop and discuss a bit more in detail, we can go over any specific aspect.
Definitely. I think like if you the tech stack diagram was quite interesting, and the framework you have developed, like it makes a very like logical approach based on the different user categories you have in the company, and like what's the easiest onboarding experience for to integrate these tools for them. Like that's
Hmm.
that's incredible. So
Yeah.
my question is like, for example, let's say if someone in AC wants to create similar framework or start with something like, what's your piece of advice where like how to get started for the intent and goals they have? And sometimes it's challenging to have funding for research at this scale, so how to take those baby steps to develop something like this?
Yeah, so all of these didn't like happen. mm, yeah, it built over a period of time. So like initially, also like all of this code was not structured. It was all kind of written. So all of the specific code features or like classes were kind of written based on project applications. So we were embedded in projects. So if the project needed form finding, we had to write our form finding tools during that project, and then it becomes part of initially. So now we see it like this, right? That it is going from left to right. You start with the source code, then there is an API, then there is user development, and then you have the plugins. But the actual production of it doesn't follow this pipeline. So generally, you might be create because you're on projects, you have to create like tools which work on the project given the timeline. So generally, we are kind of starting from the plugin where you're testing new things because you want to integrate it into the project pipeline. So writing small tools, and then once the project is done, we kind of extract the core aspects of that, and then put it back into the framework. Then that is when it goes back to the left side and becomes part of the core framework. So then in subsequent projects, we can use it again. So yeah, so it's kind of you need to build it over a period of time. So if I were to think back now, the framework wouldn't, unless you have the as a framework as a project, uh, it's always beneficial to start small, try small tools, but you keep a repo of these tools, and then subsequently, once you have a bit of a base in an understanding of how to write these tools, you can go back and start setting up the framework, I would say. So, and then you can learn from, yeah, like it's great that like all of the other companies and the institutes are also doing it all open source. So like Compass or libigl or Polyscope, they're all open source. So you can open up the Git repo and see how the code is structured there. And that is like another good way to understand how to write code or how to structure your framework. And obviously other software APIs as well, like Maya, Rhino. So we kind of have borrow heavily from the structuring of how it's done in Maya, uh, because they have the structure that there are objects and then there are function sets which kind of query on the objects. So yeah,
Mhm.
that's what we also have in our case, that you have an object class and then there is a function class through which you query. So this diagram is similar to that in that sense in Maya.
Got it. And from my observation, like the in firms there are like computational design leaders who ensures in the whole firm people adopt the, let's say, standard grasshopper practices, but also like people have their own spaghetti grasshopper code, and like people customize it based on different offices. So my question is like, are there any guidelines or principles you have developed in the firm which ensures like everyone uh, uses these tools in a particular format, and how to ensure like good onboarding experience for the new people who join the firm or people who are interested?
Yeah, so yeah, that's an interesting one. Yeah, like we have been thinking about doing these kind of templates and things, but predominantly what happens in projects is like we get involved in the project. So we as a team are in the part of the project. So we kind of set up the workflow and set up the tools required, and then pass it on to the rest of the team to use it. So we have to be part of the project in that sense, because we then only we know what is the requirement and what needs to be done, and trying to set up a workflow there for that specific project, and then implement a tool and then transfer it over, or implement a definition and then transfer it over. Or it depends on also the timeline of the project. So if the timeline is really short, then things are happening concurrently. So there is like we are developing some part of the code, someone else in the design team would also be developing their bits of code, and then we kind of come to a natural mid ground where we transfer files or transfer code or transfer geometry, and then subsequently develop the deliverables. So there's no like one set of paradigm which is uniform across all projects and across all teams, because in Zaha, because of the number of teams we have, each team has their own way of working. So you can't have a unified system, but you can have general thumb rules to say, okay, uh, having a cleaner mesh geometry is good already for rationalizing and things like that. So generally, if uh, we have found it successful when we kind of get early on in the project, when we get involved in early stages of the
Mhm.
project, it's easier to transfer a workflow. But for later stages, it is you have to be you have to adapt it on the fly to the requirements of the project.
Yeah, makes a lot of sense. And so, just for like a particular scenario, let's say you want to integrate a structural optimization component, and there are a couple
Mhm.
of ways you can go. Either you can integrate a third-party library inside it. Either you can develop your own library from scratch, or either you can do like s- freelancing or subcontract it to third-party developers. So, like
Mhm.
what are some principles you make decisions on, like what to develop next, and like uh, not to reinvent the wheel in areas. Yeah.
Mm, yeah, so in general, yeah, like kind of structure and things for early stage. So we don't implement tools for like let's say when it is finite element solvers, these kind of things like topology optimization or FE analysis or yeah, in general volumetric analysis. So these kind of FE based analysis, their tools already very robust in the AEC industry, and we tend to use existing ones like Altair for topology optimization or Karamba. We use these kind of tools which are available. But for early stage design tools, which are predominantly like thrust network analysis or force density method, which are geometric based structural form finding, we write our own based on papers because it it becomes a design tool. So then it needs to be gets embedded into, it's not an analytical tool, it's a design tool, so it needs to embed into the design workflow. Otherwise it wouldn't work, so you can't iterate through options. So yeah, so mostly like which kind of aid early stage design, we tend to write our own or try to make a version of our own based on existing libraries. But for later stages of structural studies like structural analysis, predominantly engineers do it as well in projects. But if we were to use it, then we use existing tools.
Got it. And I'm curious to know, like, so like we see often like generative design modules or like for urban planning, building design, like are there any like modules specifically like for generative design use case, or like how would you approach like explorative phase in early stage?
Yeah, so these ones, yeah, so again, so we have some classes which we kind of developing to explore these things. But in general, these are tools set up on a project, right? Because it is not like the same tool gets used everywhere. So it also depends on the comfort of the team. So it depends on because a lot of the studies in the office kind of also done. There's quite a lot of modeling aspect as well. So even though it's generative, but there is a bit of control through modeling. So it has to interface with the modeling side of things. So yeah, the tools in that sense can't be generic. Like, but there'll be generic things like, okay, there is like a field class. So if you want to explore fields, how to populate a field with buildings or massing blocks, or if there is a sign distance field, sign distance function based, generating massing options based on that. So the and then so like I don't know if you remember. So we did the science museum. There was this pod which was using like a mathematical equation to drive the generation of the form. So this that is where like generative aspect comes in, but eventually it has to tie in with the modeling aspect or the design aspects, where because not everything can be procedurally generated. So it's always a hybrid. So there is someone studying from the modeling side of things, and then there are some people studying from the coding side of like procedurally generating, and then there's always a hybrid or a marriage between the two.
Got it. So if I were to speak loosely, like one can do like form generation by any like scripting or sliders, but because you guys are integrating like this mathematical or physics based simulation inside the generation phase, like all this geometry also makes sense structurally and it's efficient in that like that adds value to this generative phase.
Yeah, that's kind of the goal as well, is to kind of inform the geometry at a very early stage, so we don't have to. Yeah, it's already in a good domain. The geometry is already in a good state, so you don't have to rationalize it later on. So try to integrate it at a very, but that's, it doesn't happen in all the projects, but that's kind of the idea, is to uh, get integrated as early as possible. So it is a bit more streamlined. The workflows are more streamlined. But
Mhm.
yeah, if it is not, but yeah, we have tools to adapt to various stages as well. So it's not like, yeah, one thing fits all.
Correct. And like from my experience, like I see a lot of AI AEC or AI architecture research published in conferences, but it's very rare to find those applications in profession. So can you like throw some lights on like how you try to bridge research and practice and also scale up this research in profession?
Mhm. Yeah, so like for us, yeah, so all of the research is kind of practice-based research. So it has to feed back into practice. So that's kind of the research framework we have also in our academic setups. It's kind of correlated. So
Mhm.
it has to find application in an architectural design scenario, and that is where we, like any of the algorithms we tend to develop or look at, is always finding an application for it. So it's not like only writing pure solving the algorithm. Yeah, we are interested in making it faster and all of those things, but major goal is to find applications within the architectural setup, and that's kind of the core fundamental aspects of code, I would say, to write code which is applicable. So that's why we have an architectural geometry is one of those aspects, trying to, and it's also the oldest research strand in the team. But now we have a bit more on like platform design. So trying to get stakeholder participation. So build up platforms for configuring housing units or interior spaces, and trying to create an alphabet of spatial modules which can be then configured by an end user. Yeah, on the machine learning aspect, yeah, like I know there's quite a lot of things kind of happening on the image based ones, but now it is becoming 3D. So there are 3D GANs and 3D related machine learning aspects, which is what we are currently also looking at, because it is again ties back to geometry, and then once it becomes geometry, it's easier to plug into practice, and that's
Mhm.
the kind of the tendency. So we kind of even in the some of the early studies we did on trying to predict topology optimization. Uh, so the prediction again was based on geometry. So you can we predict using an input geometry based on some constraints? Can we predict what is the topology optimized result? So that's where that was one of the early applications we did, and now currently we are looking at 3D GANs because it is geometry related.
Got it. And before we move on deeper into the platform design, so what I'm forcing is like one way to do like sustainable building design is ensuring optimized topology and efficient material usage. Are there
Mhm.
any explicit developments in the tech stack which you are using it for sustainability or energy or building
Mhm.
performance inside this tech stack?
Yeah, so in this one, let me see if I can find the correct image. So yeah, we have a uh, environment and sustainability team, which is kind of developing tools and workflow related to that. but we kind of worked with working with them to develop this. That's why I was also talking about GPU computing. Was kind of developed this solar tool, which is kind of similar to Ladybug, uh, but a bit more real time. So it's using GPU to compute the. While you design, you already get so the input design is on the right, and then you, because for this kind of solar analysis you need to subdivide it, you need like a lot of phases, right? Otherwise the results are not so accurate. So using GPU you can compute 50,000 phases almost parallelly. So that's why we are trying to develop this. Now it's in the pipeline, developing the Maya Solar. So it's kind of integrated uh, into the design workflow. So again, using in the interface, and then as you are modeling, you have an understanding of uh, uh, the solar radiation and those analysis. So you can almost real. This is happening real time. So you can see that as you change the geometry, you're getting a visual feedback on the right.
I, this is incredible. I love it because like I think like for playfulness in during the design phase, like the faster inference, like real time you get, like it encourages more experimental and explorative part. So this is amazing.
Yeah, and then, yeah, it's still in the early stages of development, but yeah, we can already see it's up kind of perceive its application, right? So it's speeding up, let's say, one iteration. If you were to just do it through the CPU, 10,000 phases would take at least 1.5 to 2.5 minutes after you set up to run the simulation. But in this case, you are almost getting yeah, it's like 12 milliseconds, right? So it's real time.
Okay, so if I had to decode this development, like so currently we are inferencing through Maya plugin. So the core framework people have developed, like how it take an input geometry, like and like talk to GPU for performance analysis computation, and during that calling, like there's a formula to take the sun angle and like do the compute and do it parallel. So like how did you engineer the GPU part? I think that's quite interesting.
Yeah, the GPU was yeah, it's using the CUDA, NVIDIA CUDA. That's what we use, and that's why I was giving references to the NVIDIA GPU gems. It's like a very good platform to see what people have done, how to use CUDA and GPU for computing, and that's where we learned, or I specifically learned how to code for GPU, and then yeah, so the basic structure is that each phase you are computing for each phase of the mesh. You want to compute the sun angle, right? So you have to generate the data such that at for each phase you have the required sun angle and all of the uh, you can analyze for all year long. So you 365 days, and then you have multiplied by, let's say you have 8 hours of sun vectors. Um, so that's around, I think it total around 50 million calculations, something like this, if I correct right, I remember right, which happens at runtime on the GPU. So yeah, so it's kind of very, so the problem itself is very GPU friendly because you are computing per phase of a building or per phase of a mesh, which is very GPU friendly. You can parallelize it. So the you need problems which can be parallelized, and this is one problem which can be.
I I see. And just to like pick your brain on that, so if there are like two buildings in parallel and the shadow of first building is dependent on like the sunlight of other, like what if there is a
Mhm.
dependency between like those two? It's like
Yeah,
non-linear.
yeah. So that's that one. Yes, that as you can see now, it's working on an individual one, but That is where you can also compute the occlusion in GPU. So the example I gave on the NVIDIA paper was actually that occlusion one, right? The car was getting occluded. So we can write, so the occlusion is also a GPU problem. So you can get real-time occlusion data of, let's say, if these are two buildings, the occlusion of this casting a shadow on that is also a GPU related. It can be put into the GPU, or it can be split such that you can compute it real time for each face if it is getting getting a shadow based on its surrounding. So it'll it'll be a bit slower, but still be real time. So now if this is happening, let's say 5 to 10 milliseconds, the occlusion would a computing occlusion would also take similar time, so another 5 to 6 milliseconds. So overall it will be still be 17 milliseconds, which is on so for real time, so this should be mm, close to 15. So then it'll be real time. Yeah, so it's still a bit slower, but it can work.
Got it. And I'm assuming like I was looking into WebGL, and there are like online like GPU based library which has also like built-in physics, because I have seen like fluid simulation, and it's also highly complex nonlinear problems. So there might be like built-in functions one can call for those dependencies.
Yeah, for sure. So for a occlusion, like we don't have to write the code ourselves. There are already like lots of examples of how to write things for occlusion. So this kind of answering your early question, like what would we write and what we would implement. So there is no equivalent GPU code for doing the sun angle analysis, but there is already a GPU code written by developers in NVIDIA, so which are much more robust. So there's no point in us investing and writing that code. So in that case, we will just borrow the occlusion related code and put it in our kind of framework to work with the solar analysis. So
Got
similarly,
it.
like if you have other CFD analysis or any of these FE analysis also, but FE analysis might be a bit difficult to, yeah, maybe because it is a bit more dependent on the rest of the geometry. So it's not, I don't know, if there are tools already, that's already great. I'm not aware
I
of
see.
it.
So like as AEC technologies, like one should be aware about various open source libraries, various framework one could integrate, but the then value we provide is domain use cases and customize it for and like develop like use cases from on top of it.
Yeah, as I said, exactly. So, like even so, like quite a lot of the geometrical problems to solve for fabrication, for example, like a lot of the geometry groups have already invested time and have PhDs writing papers about it. So in that case, we just try to read their papers, and so if there is code available, we try to use their code, like for quad remeshing, for example, which is now part of Rhino. But before, there was a quad remesher developed by libbygl. So before Rhino introduced their quad remesher, we were kind of using the libbygl one to do the quad remesh. So there are already tools which do that. So then we don't have to invest time in writing our own quad remesh.
Got it. And
Yeah.
can you walk us through like a project life cycle for platform design? Like I think that's very like a
Yeah.
different. Yeah. Okay. Sorry, I think you have the whole presentation, so like we can continue like for the rest of the presentation. Yeah.
Yeah, so it's kind of uh, yeah. So the stack is kind of useful. Uh, so the so for any project, so first, as I was saying, there are these kind of pilot projects. Oh, I think I have the wrong video. Okay, I think this one. Mm, I don't know if I have the correct video here. Yeah, so this kind of integrated pipelines where we trying to combine. So this was the framework kind of allows for this collaboration between multiple parties as well, right? So in this case, this was a collaboration with the Block Research Group and Incremental 3D, and made possible by Holcim. But the workflow is kind of hybrid here. So we were the design team, then it goes into structural analysis with block research group, and then it comes back to us to develop these kind of print paths, and then it goes again to the printing aspects. So all of these, uh, so the format here we had to come up with, because all of us have our own frameworks, it was easy to have like a custom transfer of geometry. So where we had to capture certain attributes. So we had like a custom JSON format, which was sending it in the right information from the design side to structural analysis. They would do the analysis and send us back the similar JSON, but with added attributes saying, okay, this geometry structurally has to be XYZ. And this kind of topology works under rigid body physics or rigid body modeling. And then we use those forces to inform the sign distance field based contouring of the geometry to generate the print paths. And then once the print path is done, it sends to the incremental 3D platform where they read that same now a JSON with print information and start printing on their end. So because of these custom platforms, with all of the AEC industry kind of investing in that, it's very easy to add custom attributes, which is kind of very useful when it comes to digital fabrication and digital structural analysis. So, but at the same time, like all of these, again, initially are all tested in sandbox environments. So this is, if the video works, it's looking at the generate one of the versions of generating these print paths or print planes for one of the blocks in the Striatus project. So again, this is a sandbox environment where we are testing the code to see if it works. If it works, then it becomes part of the pipeline and goes to Maya or Rhino. And yeah, so these kind of collaborative projects is where actually the code generally gets developed. So we have done quite a few of these over the last 10, 12 years. And each one kind of gives a feedback into structure or fabrication related things. So looking at curve crease folding with robots or printing on a formwork, hot wire cutting. So all of these, when we work on them, we develop the corresponding tool, which then gets back into the framework. Yeah, so going on to the projects. So we also do investigations to, uh, like we have to work on projects, right, and deliver on projects. So in this case, the tools which has been developed can maybe help us rationalize a roof, going from competition design on the left to uh, pre-schematic design on the right. It also allows us to negotiate with the structural engineer to say, because of the experience and the tools, we say, okay, there are other topologies which are also feasible, and then we negotiate with the engineer back and forth, and then we settle on a design. So you can see that there was a truss ring in the middle in the competition stage, which was kind of removed in later stages in collaboration with the engineer.
Hmm.
And then once that is done, at later stages, we have to create this kind of, yeah, this I think most of the companies would also be doing, is kind of generate a geometric method statement, is to how to create this geometry in a step-by-step manner. So be it be roof, facade, paneling, all these geometries will be, you need to give a step-by-step method. So the fabricator can recreate the same geometry without high deviation. So the transfer here is not the actual geometry, but the transfer is the method of saying, okay, this is how you produce any given geometry. and then setting up these kind of tools for them to say to see this kind of Power BI kind of interface to understand what's the average length of elements. Can we cluster them into bigger clusters or smaller clusters, and then finding an optimum uh, in collaboration with the fabricator in this case. So, but this will come at a very later on, like DD stage. Mm, yeah, I think that's the kind of the different tools which we kind of use in different stages of the project. And then coming, whether whether anything related to the projects you wanted to discuss specifically.
No, I think like you gave a really a good explanation of like, and I really like the geometric method statement because it really gives like a very structured approach about the development implementation. So
Yeah, and
that's
then
amazing.
it's the same. So in this case, I did just put the roof, but there are similar things for other parts. Yeah, I don't have it in this one, but yeah, you can understand. Let me see if I have it on the other side. Mm, yeah, this one. So similarly, in the same, so if we are looking at paneling of geometry, then again showcasing what are the different parameters in play to generate this geometry, and then optimize it for the given paneling strategy. So this is again looking at terracotta paneling, and then this is the corresponding statement which is given to the fabricator. And similarly for the louvers as well, again optimizing it for certain things and giving. So there is, in general, sometimes you also transfer the code, so they don't with the geometry we transfer the code, so they just use the code to recreate on their end. But if
Mhm.
they don't want the code, if there are some legal implications, then we transfer the method.
I see. And like sometimes I'm forcing like this could become very complex where in the construction like you might need to consider form work. There are like 10 types of form work and there are like location based. So what are some assumptions or simplifications you do in this approach?
Yeah, so like generally, yeah, when it comes to that stage of the project, we are more supervising. So we are just commenting on what the fabricator is proposing or the general contractor is proposing. So yeah, yeah, it's interesting we want to capture this information about how it is going to be built in an early stage, uh, trying to so let me see if I have the corresponding image. um, it's kind of leads into the platform side as to how we can. I don't know, I don't think I have it. So where we are kind of also thinking of how when we are designing the geometry, we are already considering these things. What will be the sequence of assembly? So we can think of optimizing geometry or design such that it is easy to produce them at a later stage. So that is something we want to influence our early stage geometrical frameworks with. Try to bring in these aspects about fabrication. How is it going to be fabricated? How much time it's going to take? If there is feedback about costing already, that would be it would aid design, and that is where the platform is. The next step is to integrate all of these things to bring in the full pipeline. Uh, but yeah, currently, in most of these large scale projects, these kind of form work related things happens at a later stage where we are just supervising and advising on it, not actually developing tools for that on commercial projects. But on these kind of platform based projects, yeah, we are trying to bring that into the platform, so it becomes part
Yeah,
of it.
yeah, and I could already see the value, because if you have like this fabrication based thinking in early stage, like you would avoid a lot of back and forth and design revisions if like later you come up with a form which is not feasible for fabrication, like it's a redo. So it's great that you begin it at
Yeah,
early stage.
yeah, that's kind of the exactly. So we are not surprised or we need to do revisions, major revisions at later stages. So that's why it's good to start thinking about it very early. So we already have an understanding of it. Also helps in the costing side because you are able to, the surveyor is able to cost it a bit more accurately because you are giving more information at early stage.
Mhm. Awesome. Now, yeah, I'm curious to know like how you develop the platform design.
Yeah, so the platform uh, path is, yeah, currently it's a ongoing pilot project for a residential development in Roatan in Honduras. But kind of similar ideas also leads on to the metaverse and those applications as well. But on the platform side, uh, the initial so currently it was developed for bringing in stakeholder participant, trying to get all the actors into the platform at an early stage. So the first service which was given out was like the uh, currently the user is the end user, so they can come in and configure the units they want and show a video subsequently. But the development also is again similar to coding. It was like a step by step. So it started off as a research. So version zero was like a research project at the Nahamad Bhushan studio at the DRL, and then subsequently the students they joined Zaha, and then subsequently the platform idea was then kind of using the base knowledge which was understood in their thesis project, but then adding other constraints, building up various versions of the platform. So you can see here, so the first version was this kind of game interface, which was developed at the DRL, again at the Ahmad Bhushan studio. And then this once it became part of a project within the office, it's a bit more like a storyboarding. So what do we want? So this is kind of borrowing from the animation industry. You create these kind of keyframes to say how do what do we want, what should be the features we want, what should be clickable, what are the data we want to represent. So we create these kind of keyframes to understand what the configurator should be. And then once we have that, uh, we kind of implement early stage code to see if it is feasible. So this was like a very early version of the configurator uh, in Unreal Engine. So purely looking at the UI, and so there is a bit of the UI design as well. What should be the graphics, etc. But at the same time, uh, like another concurrent development. So this is happening in like our sandbox environment to see how should be the geometry, like what should be the selectable parts. Can we create the geometry on the fly? So if there are variations we can do. So these are like kind of quick tests and kind of mimicking the options we want to give in the configurator through kind of buttons in this sandbox environment. So these buttons would eventually become these buttons, or these buttons here in when it goes into Unreal. So that was the initial thinking, and then not only the unit, trying to think of how they aggregate the types of units, kind of what should be the customization we want to incorporate, and then yeah. So we also wanted it to be showcasing structure, various structural things, uh, and then kind of interior based if they can change interior layouts, etc. So these were kind of key frames which were made, and then things were starting to get implemented in the game engine. So then again, sequencing the player actions in the game. Uh, so seeing, okay, you log in, then once you log in, you need to select a unit. Once you have the unit, you need to configure the unit, and then you set. So these are the different actions the player can take. And at the back end, trying to develop uh, like how to get these geometries onto Unreal. So in this case, again, using like a custom JSON format, so we can, so the geometries might not be created in Unreal, right? Those geometries would be, so some of them could be created in place. So that's the goal, to procedurally generate in place. Uh, but some of them you can already create this kit of parts. So these kind of are modeled or generated in other platforms, but then you transfer it onto Unreal using a custom JSON format, and then also transferring material. So the goal is, I don't know if this is the correct video. So you can see the current version of the configurator. So you join, and then the user has a grid. So if there was already user, it would also say this user, this plot is being looked into by 3 to 4 people. And then once you have it, you can choose the interior layout. You can choose where in the master plan you want your unit to be. And other reason we use the configurator is also like the visual aspects, right? This real-time rendering is like every few months it's improving very quite a lot, both in Twinmotion and Unreal. So that's also another reason why we use Unreal and setting up the gameplay there. Yeah, so this is looking at the interior options, various interior things, and then trying to keep a log of all the actions of the user. And once they're happy, they say submit, and then we get the data of, okay, this unit is what was chosen, and then subsequently design the rest of the, like the communal aspects based on the choices made by the end user. But yeah,
Yeah.
the goal, yeah.
Sorry. I was about to ask, like, if one can log all the user preference, like that could also generate a really good database of like what are the things in the geometry level or design level which particular users are attracted to, and like what are the things which people don't like. So
Yeah, so the choices are, you can, so once the user is happy with it and they press submit, so the choices, is transferred, so it exports um, like a data of what were the choices of the user. So we get that data back. So we can, yeah, it's not tracking, it's kind of tracking how many people are interested in a given block. So because it's like a chessboard, right? So each voxel is has a value to it, and if so, there is tracking of how many people are interested in this particular voxel. So and then eventually you can link that up into costing as well, right? If there is a lot of demand, then those voxel will be a bit higher rate because uh, there's a lot of demand for that. But if you go for a voxel which is has less demand, probably the costing would can be varied. So these are kind of interesting nuances you can bring into the gameplay.
mhm. And where do you draw the line between like things you want user to customize and things you want like a rule based algorithm ensuring structural integrity or feasible design? And
Mm, yeah, so the feasible design, so again, if this is the correct video. So we had this kind of kit of parts, which was developed, and then we kind of set up tools to uh, generate this variations. What are the variations which are possible and which we can be happy with? And then there was uh, also the structural engineer was also on board to see, okay, analyze, okay, these are all in feasible territory that you can customize to for so there are eventually I think five types of units. And then you can change the roof type, if you want flat roof or this kind of vaulted roof. You can change the interior and etc. So the main structural elements, yeah, there are only 5 to 6 types. So once we have the choices from the user, then we have to that model is again analyzed by the engineers to say, okay, this is feasible or not feasible. But there's already like a thumb of rule to say, so we want to bring into the configurator that idea, okay, this choice you're making is not structurally feasible. So that would it would be removed from for that part of the gameplay. So when it becomes like a multiplayer gameplay, that information would already be there, because this unit, let's say at the bottom was chosen. So if this unit at the bottom is chosen, then you can build on top of it, but you can't be cantilevering out from it quite a lot. So certain voxels here, because if the cantilever is really high, those voxels will be switched off, because if uh, you're playing based on an information of gameplay done by the previous buyer. So then a few of the voxels would be hidden.
God. And if I were to scale this globally, like what are the things like one needs to customize? Like for example, local building code compliance or egress compliance, like things
Yeah.
one need to consider.
Yeah, so all of these, so of all the actors, we are kind of showing in the first page. So we want to bring in all of those into the platform as well. So there are these planner who comes in with their regulations. So it becomes part of the framework. Uh, and then, so now we looked at the end user bit, uh, and then we develop parts of it for the developer to create strategies for. So let me see if I have the one. I think it's this one. So here it's looking kind of like a massing model for the developer. So how many units are feasible? So this comes at a very early stage in the platform. So this is not configuring, but looking at generating what given the number of units, which one has the best views, which one performs best in solar gain and etc. So you create a metrics. So this is also part of the platform, and similarly the circulation aspects and navigation planning. These things in this particular project was kind of happening concurrently, because as we were developing the platform, but these things can also be part of the goal is to have them part of the framework. So if you are making a much more informed choice, so basically trying to for each of these actors having some specific things in the platform, and this also includes the fabricator, the contractor, etc.
I s- and I could foresee like this could become its own metaverse. Like if there are various parts of land, people are building their homes, and like it's kind of a Minecrafty way of giving people the freedom and their own metaverse.
Yeah, that's the reason why we are kind of interested in the metaverse as well, like because it allows for the so it's like a natural step for the configurator, because like metaverse is kind of like home for computation. It kind of kind of builds on procedural generation of content. You can make these variations. uh, you can get customer feedback or user interaction and user content customization. So these are kind of already features which are part of the metaverse, and on top of it you get like really high fidelity images. So this is kind of why we are investing in that. And one of the early projects is this yeah, kind of urban incubator of economies. So it first to simulate the economy digitally, and then actually build them in the physical world. So that's kind of like the so it's similar to the Decentraland in that sense that there is a digital version, but if you invest in the digital one, you are also investing in the physical aspect of Liberland. So that's something we are kind of developing currently. So it's as a next step for the configurator.
Mhm. And what do you think are the skill set architects need to develop to become more at par with game designers or 3D artists to in compete in metaverse? And like for the platform design, like you mentioned about UI UX was part of it, like storyboarding. So what are the non-architectural things one should be learning or preparing?
Yeah, that's important. Like this kind of storyboarding and creating keyframes, that's very important. And then, yeah, but there's like a lot of the gameplay itself, like how to set up a gameplay, like if it's one-person gameplay or multi-person gameplay. So there are set uh, templates which you can look into both in Unreal or Unity to understand how these gameplays can be set up. So, and especially in this one, it is not like a choice one user makes might influence the choice of the next one. So it's not like you're concurrently playing at the same time, but it's kind of after one you do the next. So you need to look into read to game theory, understand game theory and a bit of that, and then as well looking at uh, yeah, this kind of technical implementation of the game, how we can get design geometries into it, how to actually do this user interface. It's like one is the design of the user interface, but the second is actually setting up, knowing the technical know-hows of how to make these buttons, right? So these things you also need to uh, develop code for that. But these things are now kind of easily available in Unreal now. So to create it again would be much faster because things are available. So there's like
Yeah.
a HUD plugin or something which does similar things.
Hmm. And like there is a difference in like a traditional design where like we have like a developer client and like depends on like participatory design. Like here when we are developing UI UX, it's a whole spectrum of users, which is like could be from young people to old people and with different backgrounds. So while developing UI UX, like was there any like a case study or user interviews which helped in this creation?
Uh, yeah, so there was a pilot group with whom this was tested and trying to get feedback from. So before the configurator was made available, so there was like a focus group who was looking at it and giving feedback of okay, this is working, this is not working. So they were kind of early kind of testers to get that feedback. Yeah. So there was a focus group.
Awesome. And uh, I know like you have some latest announcements about PUBG. So
Yeah, it's just a it's kind of yeah. We just launched the game in PUBG. It was a collaboration with PUBG Mobile, trying to design a building for gameplay. So it was kind of again looking on developing designs for gameplay, and it's kind of interesting in the sense that similar constraints that there are you need spaces to be navigable, but interesting bits is uh, you should not be easily viewable, right? You should have spaces to hide, and so you can have a vantage point, and the goal here is to not be seen. So, but in a architectural design sense, we'll think of atrium spaces with like where you can see a lot of people, right? So there's like a bit of a change there, and then thinking about on the technical side, uh, yeah, so that there is interest there in sense that you need to optimize these geometries similar to real world, but the real world is economic based or construction based, right? So you optimize geometries for that. But here the value is to optimize geometry for performance. So it has to work on a phone. So the budget here is the number of polygons uh, and the number of materials. And so we need to kind of rethink of how we can design because of these based on these constraints. So in that sense, it was kind of an interesting collaboration, and it's for yeah. So now part of the air angle map there. So all of you feel free to yeah, download and give us feedback of how you find the gameplay.
Yeah, and I was so proud like when I got to know about architectural firm is engaging with like a big like project like this with PUBG. Like literally this sets up precedents for like future people to even consider this business avenues in the place. And Vishu, what I feel is like sometimes I feel like a technological divide. So there are schools like AA, IAC, or Bartlett, we have which has like AI courses or gaming courses, and there are like colleges which are still like getting used to computational design and Grasshopper. So if you were to like hypothetically teach a course which covers like futuristic architectural technology, what are the course content you will create and what are the skills you will prepare students for being futuristic agnostic?
Yeah, it's kind of interesting. Yeah, so yeah, but for I think there's like a lot of interest in game technologies because like all of these optimization and things were being happening for a they have looked into it for a longer time than us. So uh, so there's like a lot of already robust tools inside of these game environments. So that would be one. But yeah, again, it's what I forgot. Yeah, kind of thinking about, yeah, trying to integrate like a bit of coding at an early stage. So like not everyone needs to code for sure, but if you work in teams, if there is at least one, generally in the DRL or at the Bartlett, there'll be one person in the team who is more oriented to that kind of coding aspect. So that's good. So you can like it helps you solve quite a lot of these problems. So I think that would be one of them. But at the same time, this is on the technical side, but you also need the tectonic side, right? So like you need a design and visual design side, which is kind of training your eye for things which are feasible with these tools. So you need that design exploration to check what these tools can do, and that trying to develop an eye for that. So that is kind of a skill which can't be taught, but I think which you can gain by doing things or practicing design with these tools. So it will take a while, but I think that that mix of design and computation is, I think, will be a core to design any such courses. So you can't be fully technical or fully oriented to design. So there should be a amalgamation or hybrid.
Mhm. And let's say I'm a student in India and uh, I really want to be a part of Zaha code research, and I might not be able to go to A for some reasons, or like some the best architectural technological colleges.
Mhm.
What I can do to become like really portray myself that I can get hired at your group, and like things I can learn on my own from online courses, or things that I can prove like I can add value to the group.
Yeah, so these like all of the things we kind of show this mm, yeah, we kind of learn on our own, right? So it's not like a tutorial out there where we have to we had to figure out a lot of things
Mhm.
on the go. So like so that's why there's like a lot of things out there which you can self learn, which is kind of cool now that with access to like Twitter and all of these forums, you have access to so much information and so much knowledge which you can learn from. Uh, yeah, and then trying to create a portfolio which kind of communicates what your interests are, and trying to showcase this application uh, of computation. If you're interested in computation design, trying to showcase that how you can use the tools you set up in design. So generally, uh, like people who are interested on, uh, we get a lot of portfolios which are purely design based or purely computational based. But
Mhm.
then if you can showcase an application, then it is already, uh, yeah, you're taken it to the next step, right? You're trying to think of what is the application of the tool you're developing. And that is quite important in an practice based research group, that these things have to find application. So knowing the skill is one thing, but if you can show applications, create a proof of concept, so then that will most likely catch the eye,
Mhm.
and it will differentiate you from uh, probably the rest.
That's a great piece of advice. And I also feel like if someone shows like they made contributions to the open source libraries like Compass, like that also showcases like you have the capability of like adding a good, like fun first principle of coding approach.
Yeah, yeah, exactly. So yeah, so in, yeah, most of the people, all of us in the team are like architects first, right? So we're all interest in design, and then computation uh, is also, we are also interested in computation. So it's kind of a hybrid of these two. And if you can, but as maybe as the team grows, I don't know, we might have like very specific people who are purely into coding. They might
Hmm.
also get hired, and people who are purely into design, they might also get hired. But as we are currently a small team, uh, we kind of look for people who are good in both. But if the team grows, then maybe we are looking more at specialists. But I don't know that what the
I
future
see.
holds there.
Hmm. We have a question from Karan. For learning more about advanced algorithms and geometry, can you suggest some learning resources or and also like emerge in AADRL? Okay, I think those are two separate questions.
So resource for what? Resource for
Advanced algorithms and geometry learning resources.
mm, yeah. So geometry related things. Yeah, look into. Yeah, look at IGL, Interactive Geometry Lab, Geometry Lab in TU Vienna. Look at the Geometry Collective at Carnegie Mellon, and look at, I think there is a Geometry Colloquial or something like this at Toronto. So yeah, these are kind of forums I generally look at, because people from these institutes are doing pretty cool things in the geometry based things. But on the AEC side, yeah, like the block research group at ETH, EPFL, again in Zurich, um, yeah, like also like IAC, and other institutes like Bartlett, and in US as well, like Pennsylvania State, where there are masters there now as well for robotic fabrication, design for robotic fabrication. And then there is like polyhedral structural lab, which is looking at structure related things. So yeah, I think there is like a lot of institutes you can look at, and trying to know the key figures of research in that domain. And once you know them, then you know the network. So then you know the network of people doing it, then naturally you will find resources uh, which will keep you. It's kind of like the search engine optimization you guys, like if you search a few things over and over again, then you start getting recommendations from Google, right? Saying, okay,
Mhm.
this might be of interest for you, this might be of interest. So yeah, start small, look at these small like these groups I suggested, but then through your searches and through your papers, you will understand more such people and researchers in different institutes, which you which will help you uh, take forward your research.
I see. And
And then for geometry modeling in general, yeah, like look at like so generally there is not specific to architecture, but there are these kind of very modeling of characters for animations. There are like a lot of tutorials in Maya forums and CG Persia where they showcase the benefits of modeling using subdivision modeling, and how you can start with a low polygon model and then incrementally add detail. So it's nothing related to architecture, but we kind of use the same principles when we design buildings. So we start with a low polygon and then subsequently add things and details as we design things. So there's like a lot of correlation, but understanding these kind of modeling techniques from the animator is already, because they have been doing it for quite a long time, is very useful, and that kind of gives you a skill set, and then you're trying to apply it in your field. So naturally, you would create building designs. So
that's amazing. And I guess like conferences are also a great opportunity to network with these people. So any particular conference or workshops you recommend?
mm, yeah,
Y-
conferences like advances in architectural geometry. There's a conference which is focused on architectural geometry specifically. So, and then there is Fabricate, which is looking at the fabrication and technological aspects of digital fabrication. So that's another one, but that happens every 3 years. AAG happens every 2 years. Uh, and then for computer, so SIGGRAPH is uh, like you get all the best papers in computer graphics. So that's if you can read papers from there, that's already good. And if you can go to SIGGRAPH, that's a great plus. Um, and then yeah, there is yeah, Digital Futures, the platform where you get people from all around the world coming, speaking about things, giving workshops and tutorials. So that's kind of another. But because it's online, you don't get to meet a lot of people. But if there is like a physical, before it was a physical one, before the pandemic, so you could meet them physically and network. And the digital one, it's a bit yeah, it's still a great platform. You get to see a wide range of work and then get to know who is doing what. And then most of these people are also very accessible on LinkedIn, Instagram. So you can just contact them. Once you know them, you can just contact them there.
Mhm. And I have this last section about rapid fire. So if you want to stop sharing, like it's
Yeah.
totally yeah. So in this section, I generally ask like questions, and you have like 10 seconds to answer, and you gotta keep it very brief. So let's do this. So first question is, which city is in your travel bucket list?
Which cities? I would say Roatan next to hopefully go see our building there.
Mhm. Your favorite food, cuisine, or dish?
Yeah, I'm not very particular of any cuisine. I like all of them. I generally like foods from all over the place, so I keep trying different food. So yeah, I like different cuisines, not a favorite one.
Mhm. Uh, any particular business book or technical book which made a big impact in your life?
Mm, um, I generally read quite a lot of fiction book. So I don't read business related books. Generally, I'm not a fan of that. Yeah, so I don't know. I can't recommend any. But yeah, I'm currently reading this book called yeah, I read a lot of fiction actually.
Hmm.
That's more of my interest.
I see. And your favorite movie?
Movie. Okay. Again, I'm like a lot of movie buff, so I see quite a lot of movies. Recently, I've been watching like a lot of regional movies, especially in India. So from the Malayalam movie industry, because there's like a new age kind of films coming there. So I kind of like that. So there's a few actors there I follow and try to see a lot of their movies. But like an all-time favorite, maybe like The Godfather is kind of my all-time.
I see. And how does a day in your life look like?
Yeah, it's regular, similar to everyone else, I think. You kind of yeah. There is you go to the office, and then if it's a day of meeting students, then I also go to the UCL. Yeah, predominantly it is uh, yeah. You get up and go to the office. Yeah, that's something working from home you kind of miss is now you don't meet people. That's kind of the thing I miss. So now it's because of hybrid. I tend to go a couple of days a week to the office, meet people, and then also go to the UCL one of the days of the week. You know.
I see. And is there anything you wish you would have done differently in life?
Mm, uh, yeah, so I would wish I knew all these tools before. So then we would be doing a lot more things. Yeah, if it was, let's say, if we had learned these tools in the undergraduate, then you naturally get a head start, which is something, if it was feasible or the institutes are now opening up to such things, it's all already there's a lot of advantage in knowing it before you come to the masters. So, and especially we see that in like all the new students who come in, like they generally know a lot of grasshopper and these things before they come to the institute, and which was not the case for me personally. Like I didn't know so much of what the students know now when I joined. So that, maybe a head start there would have been good.
It's commendable, like the amount of things like you're doing like in such a short period of time. Like it's amazing. And lastly, like what's your vision of futuristic architecture look like in 2025? Like
Yeah,
new
it's going
business
to be
model, new avenues. Yeah.
yeah. So yeah, currently like the metaverse and cyber physical spaces are getting a lot of traction, and there's like a lot of interest. And I think there will be so because we as designers will also be creating these NFTs, and there'll be a lot of people doing it and designing for virtual spaces. So I don't know if there should be maybe a contractual change there, because like as a designer you're contributing to the NFT, and if the NFT gets a lot of money, there should be a contractual change in how the designer gets paid, I think. So, and then in terms of yeah, so there is this kind of lot of cyber physical spaces which are kind of it's going to be interesting in the next few years. There's going to be a lot of virtual equivalents. So like galleries will have a virtual gallery where they can showcase more items or keep changing things more on a more frequent basis and get feedback on a virtual gallery. And similarly, you can have create economies virtually first, see if things are feasible, and then you build. So this kind of hybrid things are going to be quite popular, or I think going to trend in the next couple of years. So the design of buildings also will naturally change using when you're having these constraints.
Awesome. So my last question is there anything which we didn't cover in this interview and you would like to share as a concluding statement?
Yeah, you can generally finish with a thank you slide. So, and you can, yeah, feel free to contact us. We are quite open on all the social handles, like on LinkedIn or Instagram. Yeah, if you have any questions to ask, yeah, feel free to just ping us and we will answer it.
Yeah, and I must say, like, Vishu is very approachable, and when I was brainstorming about this session, it was an amazing uh, experience, and Vishu is very supportive. So definitely, I'll also share Vishu's Instagram handle on the video description. But thanks a lot, Vishu. It was like quite insightful and amazing interview, and uh, thanks for
So,
being so honest and sharing all the thought processes.
okay, no worries. Thanks for the intro. It was a pleasure seeing and discussing things. So, always a pleasure.
Yeah.
Thanks.
If
Thanks
you
for
are
the invite.
visiting Chicago, let me know. We should definitely meet.
Visit, visiting where? Sorry.
Chicago.
Okay. Yeah, maybe maybe Arcadia this year if it happens physically. Maybe we meet there.
Yeah, definitely. Awesome.
Cool.
Have a good rest of your night. See you.
Yeah. Thanks. Thank you.